All right, thanks, Christina. So Ashley, I know, actually has a poster herself, so she's going to run on down to her very exciting poster. And I don't want to keep everyone too long because the posters really are fantastic, and I want you to have time to look at those. I do have, so I've been trying to keep track of questions that weren't answered. The speakers have done a great job of answering questions in the chat, and I see people have been answering each other's questions, so that's fantastic. Um, but I do have 4 questions on my list, and then we'll see if there's anything else that we didn't quite get to. I want to make sure we don't skip those. So the first question is for Garrett Schieber. Um, and this one was from Kirby Runyon. So Kirby asks, Garrett, with the deep regolith being colder than the interior of the thermal tent near the surface, are you confident the vapor will come to the top and not be driven even deeper underground? So Garrett, if you're there, go ahead and reveal yourself.
Yeah, I was really hoping I was able to answer this one because I meant to mention this in one of my later slides. Um, but unfortunately, just with nerves, forgot to mention it. So uh, as this volatile or H2O sublimates, it can transport in any direction, right? And I think that's what she's asking about. And so, however, basically, as it transfers into the colder regolith, it's going to potentially phase change and deposit, which is going to fill that pore and make it less likely for additional vapor to transfer further into the regolith. In addition, as you move down into the regolith, you have a density stratification, and it gets more dense as you move down. And so actually there's a lot less resistance for this sublimated um, water vapor to move up rather than down. And so the answer is it goes everywhere, but um, the majority of it should actually come out, which is good news for the technology.
All right, thanks, Garrett. Good, great, very clear answer. I was wondering the same thing, and you answered that very well. All right, so Chris, is Chris Agnew still online? All right, perhaps we lost Chris. That's okay. In fact, I'm just going to put these questions out there in case anyone else from the Viper team or anyone else from the Honeybee team who's been involved in that in the Trident development could chime in on this. But there were a couple of questions. So Kevin Cannon had asked whether there was any concern about tribocharging when using Trident in PSRs. So if Tony or Dan or anyone else on the team is online, would anyone like to take that one?
I don't know, this is Jen. I don't know if Tony is still on the line or not, but that has been looked at and has been looked at during the testing. I don't know how much of that is publicly available or not. So I'd rather have Tony address that.
All right, thanks, Jen. And next we had Shuai Li. So Shuai asked whether the drill would create enough heat to melt water ice and other potential ices such as ammonia or methane. Anyone want to take a crack at that?
So again, that has been also addressed in field campaigns and in testing. And no, we should be fine in that respect.
All right, thanks, Jen. You are going to be our point person for the last Viper question, which is a little more technical, but this one was from Deep Joshi, who asks if there are plans to use the drilling data in real time to optimize those operations, and whether the drilling data would be used to get at stratigraphy. So I think the answer to the second part of that is yes, that there are plans to sort of take bites and get at stratigraphy. Jen, do you have any idea on whether there are plans to use the drilling data in real time? Is that something that can be done? I know you've done a lot of work looking at the ConOps for a mission like this.
Yep. Yeah, the short answer is yes. And not just the drilling data, but all of the other instrument data and rover telemetry data as well. So that's one of the beautiful things about doing this mission on the moon, is that we're so close that we can essentially operate in near real time. And so it is part of the science architecture and the science operations to be getting that data that's being collected from the rover back to the mission control center and to the science backroom team, so that we can make decisions and make tactical operational decisions in real time, using what we've learned from the data that the rover is taking back. And this is one of the exciting aspects of this mission, and also one of the challenging aspects, because we have never operated a planetary rover in this manner before, taking near real-time data that's coming back, assessing that information, making sense of it, and then turning around and making tactical decisions to affect the actual operations of the rover itself. So the answer is yes, and that's I think one of the most interesting parts of this whole mission.
Right, wonderful. I certainly agree with that. And I was doing my best to keep track. I think those were actually all the unanswered questions we had. I think the speakers and everyone sort of chimed in and had a very productive discussion on the chat. But was there anything else that I could ask an hour of questions myself, but I'm not going to do that because the posters are much more interesting.